Hello everyone, my name is Riya Tiwari and my dissertation topic is called An Urban Utopia, and I am proposing an urban laboratory to revive the National Rayon Corporation Colony. The aim of my research was to explore utopian dreams that has existed in architectural movements and using it to derive a toolkit to intervene in a dystopian-like scenario. The process consists of first understanding the concept of utopianism, then analyzing utopian manifestations from a part to a whole approach, and finally understanding the counterpart of utopia, that is the concept of dystopia. By identifying experimental architecture that has redefined the way we build, and also reading narratives that speculates and shapes the cities of tomorrow, I came to following conclusions. Utopia cannot be used as a blueprint. Utopia cannot be achieved or designed, but it is something to be strived for. What may be utopian today may not be the same tomorrow. To revive a city from the state of despair, it is essential to document the array of things that led to the certain disposition of the city's conditions. The National Rayon Corporation Company, known as the NRC Company, was once a thriving township with amenities like school, hospital, clubhouse, housing and guest quarters, shopping center, recreational space, etc. A chemical and textile manufacturing unit got established in the year 1946 in the town called Mohone, also known as Ambivli, which is along the outskirts of Kalyan in Mumbai. Such an establishment resulted in Mohone to become magnet for business opportunities, but due to consecutive losses faced by the NRC company, it went into a complete lockout in the year 2009. Most parts of the town now consist of dilapidated or abandoned buildings. Few workers from the company still reside in such conditions because of an ongoing dispute of unpaid dues of the time they worked for the company. For some, NRC colony is their home and they have nowhere else to go to. After a series of interviews with residents and the ex-staff members of the company, and from my personal experience, having spent most of my childhood living there, I found there is a mix of sentimental value and expectations from the colony's development, along with it having a high potential too. I decided on taking the company land as my site for intervention as it is an already established focal point of the city. The land of dispute will serve to multiple set of stakeholders. The programs include rehabilitating the company workers with improved amenities and providing income generating opportunities and community strengthening. To initiate future development and to pull investors in this area to ultimately profit the landowners, a commercial sector is established. Also bringing the location in public domain as an experimental center for visitors and design enthusiasts. What makes this intervention universal is the toolkit that can be used in similar scenarios where the host site is in state of despair. The urban laboratory is one such prototype from this toolkit. The approach of this toolkit is a part to a whole process where the programs or components from this toolkit are plugged into the city. These are flexible and prefabricated units, which are divided based on programmatic components, structural components, and services. The design is based on architecture of plugin, where a framework is used to plug in components from the toolkit that are in the form of prefabricated units. The urban laboratory strives to establish a designer's hub for experimentations with construction and design. One can buy, rent, invest, or pay visit for an experience at Urban Laboratory. It is also compatible with the Internet of Things for users also being able to interact with the virtual form of the building. The housing units are sold as commodities to users, and these commodities will suffice the dues of the workers of NRC colony. For a common structural entity that can comply with various user needs efficiently, I intervened with pods that can be stacked in a designated grid of 3 meters. The pods can be used as housing units, food outlets, as well as a kiosk. At Urban Laboratory, the living, working, growing, and leisure is redefined. It consists of condominiums, housing units, aeroponic farms, and commercial and leisure spaces. One abutting road to the site comes from the existing colony, and so that portion will host private programs. The other side has Ambuli railway station and a main road next to it, so it caters to public activities. There also exists an independent railway line to the site that was used to bring in goods to the company, which I'll be reviving and extending on the site to move prefabricated pots. A structural grid of 10 meter by 10 meter is used, which can be expanded uniformly further. A crane track is then established around the railway track. This is the entrance to residential units, and this is for visitors. This is the service entrance. On the center is assembly unit for pods, where conveyor belts are used to transfer the pods from different stages of construction, and finally to the other end for deployment. Coming to the residential units, the top right side of the screen shows the components that is used from the toolkit to build the structure. This typology consists of inbuilt aeroponic farms that is centrally connected to pneumatic pipes that transfer surplus amount of vegetables grown in individual unit to the store for sale. Next typology is a two-bedroom house with an additional studio space for flexible use or incrementation. Social spots are created around the housing units like parks, open library, etc. This is a section through the residential units. This is a drone view of residential units showing bridges connecting it to different towers. Moving on to condominium tower. It is for people wanting to reside at urban laboratory on temporary basis. These units can be customized according to individuals or companies' need. The tower profile allows it to be incremental based on the footfall. The entire unit is automated and can be controlled from a single device. The ground floor of the tower consists of shared amenity spaces. And this is a typical floor plan. The in-between floors acts as refuge space. The cranes on the site are used to plug in pods to the towers when needed. Now looking at commercial and leisure towers. The commercial tower hosts exposition on ground floor. There is exhibition and market space on the first floor. Second floor consists of event spaces, and above that are two towers of working pods. This is a section through the commercial tower. A diagram showing how different modules are plugged into the tower. The service ducts are placed on the rear side of the building and are made of prefabricated RCC panels. The floor spaces are flexible. For example, a concert space can be converted into a containment zone, and the exposition hall can be rearranged according to the type of the events. The Tower of Leisure attracts visitors with exciting rides and also provides recreational activities for the residents. Ground floor consists of food court. Above it is a textile museum to inform people about the town's history. There is a game zone that consists of anti-gravity rooms, slides, and virtual reality PlayStation booths. There are sports rink on 5th floor and a swimming pool that harvests rainwater. On the top, user can take a cable car ride that moves over the entire of Urban Laboratory. A view of Urban Laboratory from a cable car. This is a section through Tower of Leisure. Coming to the geodesic dome on the site. Aeroponic farming is done here on a larger scale. There are pneumatic tubes spread across the racks to transfer vegetables into centrally placed packing room. The airtight canister carry vegetables on the conveyor belts, finally dropping them to processing unit. Solar-powered trains enter the dome and carry vegetables to distributors, who then supply these organic vegetables to markets in immediate vicinity. The dome skin is made up of ETFE air cushions that allow sunlight to penetrate inside, allowing crops to grow. This is a cross-section through all the towers. A view of arriving of pods to be placed in the tower. A view of the piazza space in the front to perceive the tower's surface, billboards and LED screens that are attached to it. An elevation showing the composition of pods in the main structural framework. Following are some of the illustrated views of the design. In ARD, I have looked at specialized services like solar-powered railway and pneumatic systems, site service layouts, dome and condominium construction details, steel construction joinery details, pods, drones and aeroponic details. The design details of solar-powered carriage system. The engine battery stores solar energy and a charging outlet is provided which is connected to solar plant. Pneumatic pipe system where goods can be transferred through air suction pipes. The centerline plan in a grid of 10 meter by 10 meter. The blue color shows water supply. The yellow color shows electrical supply. And this is a firefighting layout. Some of the construction details of geodesic dome. An animation showing the construction process of condominium tower. Main tapered truss beams are placed, then the core of lift is constructed, floor beams are placed, then the slabs, the staircases and external walls are constructed, and finally the pods are placed. These are typical column to beam connection details of main steel structure. Drawings showing flooring details and the sliding detail of pod over the slab. Clamps with rollers are attached at the end beam for pods to easily slide into place. This is how a pod will be deployed from crane to the floor. These are different orientations of floor details for different module types. A sectional detail of leisure tower, a detail of tower parking system, and the parts of cable car system. A 1:25 scale model showing different construction materials of a pod. An animation showing construction process of pods. The two main steel frames are connected by purlins and vertical brackets, which is then filled with spray foam insulation. The exterior is made up of coated aluminium composite panels and the inside paneling is of gypsum boards. At the end, the furnitures are plugged inside the pod. These are the working drawings of pod. A diagram showing how pods are connected. This model shows how the pipes are infilled to the pod. The blue indicates conduits, the red pipes is of water supply, and the yellow ones are soil and wastewater pipe. Details of steel staircase connecting the pods. An experimental drone hive is created on the surface of the tower. The drones are used for surveillance and to transfer packages on the site. This is a drone circulation diagram. The barren site did not consist of trees. These aeroponic trees provide a fresh ambience to the residents. Some details of aeroponics farming racks. Glimpses of the Urban Laboratory website. Concluding on a note that an architecture which indulges people in its experimentations and strives to keep expanding flexibly will make an ideal urban utopia. Thank you.